Hello everyone, and welcome to lesson number 4 in my Practical Python video series. Today we're going to be talking about something called front end, which is programming for people who will be using your program but don't care at all how it works. They just want it to be quick and easy, they want it to work, an end user. Specifically, we're going to be talking about the library Kinter. I call it Kinter. I've heard TK Inter and other pronunciations. Pronounce it however you like. People will know what you're talking about. Very few things are spelled with a TK in front. So to begin, we of course have to import to Kinter. This is something else that comes with Python. It's built in. It didn't used to be, but now it is. We're going to start with equals to Kinter.tk. And we'll do this. Something like this. And then of course we need main loop. So, this is very, just about the most basic Kinter script we could have. If we run it, we get this little blue window titled demo. So here we're declaring a new variable, calling it root. This equals to Kinter.tk. This is a very special built-in function in Kinter. This is saying you're making your main window that's going to show up when people run your program. This is a built-in function. We're running this function on our variable root. Its title. It takes a string as an argument, one string, and I just named it demo because we're demonstrating Kinter. And then root.configure. It takes all different kinds of arguments. It's kind of weird in that each argument is something equals something else. Like this whole thing right here is the argument. It's kind of nice though because configure and lots of other functions accept a whole bunch of different arguments. Like there's one for border, I think, all different things. And by having it background equals blue or something equals something else, whatever, separated by commas, you don't have to remember any specific order. Most functions in most libraries, you have to pass in, okay, this is what I want and this is how big it's going to be and whatever, and just pass in a bunch of numbers or whatever, and then the order of the numbers matters. Here, and you have to put in all of the arguments. Here we can just change the background to blue if we want. We can change the way the borders are on the window, all different things. And we can just do one or the other or whatever. Not only are we doing it in whatever order we want, we're also picking which things we actually want to configure. So that's nice. And then this last part here, I'll talk about very briefly. Basically, just make sure this is the very last line in any Kinter script. This kind of gets everything going. If you look here in the task manager, these are processes. So these are applications. This is going to be your Microsoft Word, your Internet Explorer, your whatever, your actual applications. And then down here, these are processes. So these are sort of like sub-programs that are spawned by applications that kind of keep everything running. I like to think of it as a program or an application is like a sailing ship or a train or something, and then processes are people running around on the train or the boat, keeping everything going. Python usually just has one process. No matter how big your file is, no matter how much code you have, it's all going to run through one process. With Kinter, however, Kinter makes its own process. It's either a process or a thread. I'm still not super clear on the difference. Basically, there are two different ways to have your computer do more than one thing at once. You may have heard of like dual core processor, or like quad core processor or whatever. If you have more cores, that means you you can run more threads, more processes at once. So this is just to Kinter, making it so the windows and everything that are happen in their own processor thread, whichever, I don't remember which. Whereas your loops and your if statements and your functions and everything else that we've learned, that's going to be happening in your own thread or process or whatever. So yeah, if you're not interested in what this actually does, just remember you have to have it as the absolute last line for everything to work properly. Now, as I demonstrated right now, when we run it, it just makes this little blue box titled demo. That's not very useful. So let's add some functionality to it. First, we're going to add a label. So we'll do example label equals Kinter.label. This is a built-in function. We're passing in root. Here the order does sort of matter. Text equals, say hello. And then we have to actually put it in there. And as usual, I'll explain everything in a moment. Okay. So here we are making a label. That means we're making text appear in the window. The first argument has to be where you want that label to go. So right now we only have the one window. We just have root, that blue box. So we're putting a label in there, setting the text of the label equal to the string hello. So here we've made a label. We've made a Kinter label. Now we have to actually put it in the blue box. So xlabel.grid, this is a built-in function that you can do on labels. Row 0, column, go to column 0. There are two different ways to place objects into a Kinter window. There's pack and grid. Pack, you just say like pack left or pack top or whatever, and it just kind of like shoves it in there and like tries to make it fit. I found it doesn't work super well. It's kind of annoying to work with. And you really have to pick one or the other. You either have everything be pack or everything be grid. The two systems don't play very nice with each other. So I just use grid all the time. You say row equals 0, column equals 0. That's just, we only have one thing, so of course it's going to be in the top left. If you want to do like row equals 1, then the grid system that's built into Kinter will just automatically make another row or different columns. You can have things span more than one column, so you can have like a button here and a button here and then an image here, and just everything just looks very nice when you use grid. Everything's very easy. And then pad X and pad Y, this is how many pixels of space we want to go around our label. So if we run this, there you go. This is kind of hard to move around. This is our blue box. This is our label with the default formatting and everything. Remember, we didn't set the text color or anything, but we could. And you see there's 10 pixels on the top and bottom and 10 pixels on the left and right. So that's a label. This would be the title of something, or if your program is for making projects of some sort, this could be the title of the project. And then something else could be the size of something, or how many of something you have, or whatever. You'd use this for displaying information. Another way of doing this, which I find to be very, very helpful, we're going to declare another variable. We'll call it label text equals this function is capitalized, which is very strange in Python, but whatever. It's capitalized in both places. And then do here text variable equals hello. So what's happening here, oh, no, this isn't what we want. Lab text. And also, before I forget, so instead of setting the text of our label equal to just a static string that's never going to change, we're setting the text in the label equal to this text variable. This string var is what it's called. So here we're making a new string var. This is just something built into Kinter. That whoever made Kinter made this up. And then we are setting the variable, the string var dot set, and then our string. So if we run this, you'll see it looks the same. However, whenever we want to change the text, for example, if whoever's using your project has saved something and they want to start something else, so you have to change the title that shows at the top or something like that, you can do, I don't know, bye. And you didn't actually see it be hello because we don't have any sort of a delay in between, but just to give you the idea, whenever we do this variable dot set and then some text, this label will automatically instantly respond. The text will change. Not only is this very useful, it can make things much more efficient, because say you have a whole lot of labels. You have a menu that's going to show a whole bunch of external files using stuff that we learned from the last lesson. You don't want to have to keep track of this this variable, because perhaps this is like for X label in, and then there's the list of file names or whatever. You're not going to have a variable that you can use to get back to this label. You'll have no way to change the text, because there is a way to change the text manually of a label, but only if you have this variable still. So by having a string var, you don't have to keep track of this label anymore. You can just keep track of the string var. If you have something displayed in multiple places, you can have this be the title of the project or whatever, and then maybe you want that to show up in the title at the top of the window, and then you want it to say it somewhere else, and then they open a window and it has to say it somewhere on the pop-up or whatever. You don't have to set that text manually every time. You can just set all the text variables equal to this string var, and then whenever you want to change the name of the project or whatever you're doing, you just change that string var, and all of the labels will automatically respond all at once. So just very, very efficient there. Now let's do something a little bit more interesting. Let's make a function, and all it's going to do is change this. So we've made a function where whatever we pass into the function is going to be passed to this string var's .set function. So you're going to pass in a string here, and the value of this string var is going to be set to that same argument. And now let's do example button equals to Kinter.button. Putting it in root again, and buttons you don't usually change the text of, so I'll just do a static text for that. That each method has their place. And now we've got the function of the button, and we'll just do something like this. And then of course we have to put the button in there. Put it on the second row, put the same column. And we won't worry about the padding or anything for now. Save and run that. You see now we have a label and a button. We push the button and the label changes. So what just happened? Buttons have a unique argument command. This is what happens when the button is pressed. So ordinarily that's going to be a function. If whatever function, in this case change text, didn't take an argument, we could just do the name of the function just like that, and that's it, with no parentheses at the end. But because it takes an argument, I'm not really clear on why this is, but just know that you have to do this. If this function takes an argument, or if you just have empty parentheses if it doesn't take an argument at the end, when you make this button, this function will run. So I can show you. Alright, yeah, we'll leave that in there. So save and run that. You see it already says new text. We haven't pushed the button yet, but it says new text. And that's because Python is making the Kinter button, and then it says, oh, change text and pass this into it. We gotta do it. And it just runs it, even though you're passing in this function and this argument as an argument in this Kinter.button function. So this lambda keyword is basically just telling Python, don't do that. Pass this whole thing in, run this when the button is pushed, but don't run it right now. So that's that. And then this is gridding, which we already talked about. So when we push the button, we run change text with this string. New text gets passed in as argument, and then we set string var's value equal to the argument, which is new text. So then this label responds, and to show it one more time, the text of the label changes. And you can imagine much more interesting and useful stuff, not just changing the text of a label. You can put whatever you want in this function. Let's do something even more interesting. Let's make a prettier button, because why not? So for this, we're going to have to import a couple more libraries. Oh, we need pill. This is something that doesn't come with, or it might. I'm not sure if you have to download this separately. Either way, you have it now. So you gotta import these things, and now let's set our button, instead of having it be text that says push me, let's have it be an image, because you can make things look much better by doing that usually. Open, and I have one prepared, just random image. So with this function, you're opening an image, and in this case the image is just right alongside the Python script, so we don't need to say like the name of a folder / this or whatever. And then this is converting the image to work with Kinter, because if you try to just pass this in, it won't work. You have to convert it like this. So now instead of text, I'm going to do image equals image, and this is a little bit weird, just a little nuance. You need this extra line here. When we make the button, we declare the image to be img that we made up here, but then we have to do this down here. If we don't, then the button will kind of forget what image is supposed to show. It's kind of weird. I don't know. Anyway, we run this, and this is our button now. Yeah, I made this. Maybe I should have a video series on Photoshop. That might be fun. Anyway, we push the button, same thing happens. It's just now our button is an image. And you see this border here is kind of relief. You can see it's kind of got that shading. We can change that border to all different things if we want. So that's really basic to Kinter. We have labels and buttons. And you can imagine, now that we know how to run a function with a button, we can run a loop, we can run functions, we can do all sorts of things. And control it all from something that's very pretty front end. We can control something from a front end, sort of a UI, a user interface. Just a couple more things while we're here. There's something called a top level, which is, put it up here, symbol top level equals enter dot top level, and we'll give it a title. Okay. So now when we run it, oh wait. Oh, because this is not supposed to be capitalized. There we go. So now when we run it, this little pop-up comes up. So I use this for somebody's working on something and they hit save, and then you have a little window pop up that says save as, and you have a text box for entering the name of it, where they want to save it, etc. Or if somebody exits it, I'll show you how to do that in a minute. You can say, like, are you sure you want to exit? You'll lose your progress, whatever. All the stuff that you've seen before. Working with top levels. So usually you don't want this top level to just happen when your program runs. So here we've made our top level. To hide it, and it's not like it'll pop up and then go away. It just won't come up. Withdraw. So now we run it. The top level pop-up thing exists, but we don't see it anywhere. It's not down here in the task manager, it's gone. And then perhaps on top of changing the text, we will make our button show our pop-up. That's going to be example top level de-iconify. And we push our button, and there it is. And the text changed. So if you want to get rid of a pop-up or just some other window, you use withdraw. And if you want to show it again, you use de-iconify. I don't know why they're named this. I didn't make that up. Sometimes you'll have something where someone could cause problems for themselves accidentally by trying to save something. They have the save as window up, and then they go back to change something, and then when they go to save, the changes that they made don't actually save, or they could open the save as window multiple times, all kinds of stuff that would confuse an end user. So to prevent that from happening, you can do, here we're de-iconifying it, so we're making the top level show. Dot grab set, and we run that. We push our button to make the thing come up, and now you'll see that we can do whatever we want with this. If there were buttons or whatever, we could mess with stuff on this pop-up, but we can't mess with anything on here. We can move it around, but we can't push the button. If there were text boxes in here, we couldn't type anything. It makes it so that this is the main window, basically. You can't access this until this goes away. If we hit X, then, well, this is a good example actually, I'll keep this. We're trying to de-iconify something that does not exist because we just hit the exit thing instead of withdrawing it. The withdraw thing hides it, so it still exists, and then when we go to de-iconify it, it's showing it because it already existed. When I hit the escape thing, the little red X, that didn't withdraw it, that just deleted it, so then de-iconify stopped working. But you get the idea. You de-iconify to make the pop-up show, use grab set to make it so you can only work with that window, and then when you're done, for example, let's make another button. We'll call this top button. Make another function. Def hide top. And all that's going to do is top level dot withdraw, and then also this part is important. So top level dot grab release, and this has to go in between here. And this can go up here actually. Keep things organized. And this doesn't go on root, this goes on top level now. And we'll just make it text. Alright. So you see now, we push this button, and a pop-up comes up, and I forgot to grid it, so this isn't going to work. Sample top button dot grid row equals 0, column equals 0. There we go. Now we do it, and now there's a button in the pop-up, and when we hit that button, this is not supposed to be change text. This is supposed to be hide top. There we go. Alright, so now push the button, little pop-up comes up, we hit this would be a save or whatever, hit that, and now we have our main window again. And now we push this, so we don't get errors anymore. Should probably explain things. So we made a function here. This is just withdrawing, this is just to hide the top level like we had before. And then top level dot grab release. Remember before we had it so you could only mess with the little pop-up window, you couldn't mess with the big window. This is just undoing that basically, making it so you can select whatever window you want. Very important to do this. One very last thing that I think is kind of nice. Let's do this. So we're going to import a couple more things that come with Kinter. Okay, message box and okay, file dialog. Okay. So you may have noticed that the windows that come up look very much like Windows, the Windows operating system Windows. That's because Kinter uses the default formatting and everything of your operating system. So if you run this exact code that I've written on all different operating systems, it would look slightly different. You know, if you have Windows 7 versus Windows 10 or whatever, the window that comes up would be different. This works on a Mac too, by the way, in which case it would still look different. And one of the nice features of that is, let's do cancel, and let's just put in here a warning. Are you sure? Oh, are sure. Are you sure? And then let's do con equals warning. So we hit F5 now, do this, and now when we click this button, we get this additional window. This is a very, very nice feature. You could trigger this. Remember, we only did this in one line, this whole window here. We didn't have to individually make the boxes and set the text in the window, in the buttons. This is the default Windows icon. I just picked one. Literally all we had to do for this window to come up was put this text and this text. And the best part about it is that you see here I did x equals this whatever thing. I print x, and then I hit OK. We get true. This thing, this whole thing that makes that nice window for us, that nice official Windows looking window for us, it returns a Boolean depending on whether or not somebody hit OK or cancel. OK returns true and cancel returns false. So then you can have your whole exit function wherever you have that. You can have that run if you say, are you sure you want to leave? And then if they hit yes, then exit your program. If they hit cancel, then just close the window, don't exit anything. If certain things need to happen every time your program exits, everything gets saved properly, everything gets closed properly or whatever. We can do other things. There's message box, show warning, and then we can just do that. Doop. Yeah, see, this doesn't have an OK or a cancel, it just has an OK. So this would be error whatever thing you wanted me to do is not found, or error your system does not support this thing, or whatever, something where your end user really doesn't have a choice. You're alerting them to something. You can use that function. And one last thing that's really nice is x equals tk file dialog dot ask directory, and then we'll print x again. Oh, this is not supposed to be capitalized. Run this, dedupe, and now this window comes up. And remember, we didn't have to populate this list, we didn't have to put anything in here, we didn't have to make these buttons. You just pick something, hit OK, and there it is, the file path. So that's really nice for your program makes projects, and you have an open button, the person hits open, and then you can just show them, okay, which thing do you want? You click it, and then it automatically, without any input from us, gives us this file path, or whatever the person clicked. And then you can have code to read and write external files, like in the last lesson, plot things, or display different images, or whatever you want to do. All with just this nice little line of code. So that's about all I have to say to Kinter and UI for this lesson. I hope you found it informative and helpful, and I hope you enjoy the rest of the series as well.